happy to hear from Minister Renner was just the talk around leaving a legacy to future generations, because quite honestly, that's why I do what I do for work, and that's why many of my coworkers do what they do as well. So today, I'm going to talk specifically about oil sands and some of the gaps in management that are occurring in oil sands water management. So just a little bit about the Pembina Institute, and I'm going to have to go through my presentation fairly quickly just because there's so much to cover in such a short period of time. But if anybody has questions or comments, I'll be around at least for the rest of the morning and happy for you to come approach me. So the Pembina Institute's mission is to advance sustainable energy solutions. We do that through research, education, consulting, and advocacy. We were founded in 1985. We're a Canadian non-profit, non-governmental organization, and we focus on energy and environmental issues. Our position on oil sands development is not that oil sands development needs to be shut down, but just that it needs to be done responsibly. The current environmental impacts need to be addressed. There's environmental limits that exist, and science-based thresholds need to be determined, and the development needs to live within those thresholds. And that revenue from oil sands development could potentially be used to diversify to a clean energy economy. And meanwhile, we do believe that there should be a pause on approvals until environmental management is given the opportunity to catch up. So some of the gaps that I'm going to talk about through my presentation are the fact that water flow should be halted during low flow periods, such as Minister Renner also alluded to, that there should be a prohibition of liquid tailings, enforcement of the Tailings Directive 74, transparent reporting for water withdrawals and seepage within the oil sands area, as well as a wetland policy that compensates for wetland loss across the entire province, and regional limits need to be established as well. So it's hard to talk about oil sands without having a little bit of the basics. We're talking about a development that could potentially occur over 21% of the province. The oil sands make Canada only second to Saudi Arabia for proven global oil reserves, and 175 billion barrels of proven reserves of the 179 in Canada are from Alberta's oil sands. So we're talking about a really significant resource. So there's two ways that you can extract oil sands. One is through mining. Mining began over 40 years ago. The surface mineable area is almost 5,000 square kilometers and represents about 60% of the current oil sands production. And this only happens when the bitumen is close to the surface of the earth, or less than 100 meters. It takes net 2 to 4 barrels of fresh water to produce 1 barrel of bitumen from oil sands mining. That's after the recycling takes place within the process. There's wetland and peatland loss associated with mining. Just due to the nature of mining, you have to drain the wetlands, and when you're digging a pit, you're obviously getting rid of the wetlands that are on that area. Liquid tailings are stored in tailings ponds, which I'll go into in a little bit more detail, as well as there are seepage concerns. So the water allocation for the mines is equivalent to the water needs of a city of 4 million people. So there's a lot of water allocated to the oil sands. Does that mean that that's what they're currently taking? No. As you can see, the diversion rate for 2008 is a lot smaller than what they're actually allocated to take out. But what that means is that the potential is there. The potential is there as production increases and projects expand. The potential is for there to be a large amount of water being diverted from the Athabasca River. And so the forethought and the planning really needs to come into play to make sure that this is all done properly. In situ development is the other type of extraction that can take place in the oil sands. It's where steam is injected underground to make the bitumen more viscous, because bitumen isn't like conventional oil. It's actually the consistency of a hockey puck at 11 degrees Celsius. So you put the steam down into the well. Hopefully, you just basically make the bitumen less viscous so that you can bring it up by another pipe. The area available for in situ development, which is deeper deeper bitumen is 30 times as large as the area available for mining. It'll potentially be 80% of oil sands development in the future. While there are different concerns associated with it, groundwater is the main type of water used for in-situ development, so there's groundwater concerns. There's a need for mapping of groundwater quality and quantity, especially in the northern part of the province. It's a very complex system, and we don't know enough about it in order to manage it adequately. It takes less, on average, it takes less water to produce 1 barrel of bitumen from in situ. It's about an average of 1.1. And operators do use saline water where they're able to in situ, but it depends on where the project's located. And there are disposal risks. There are not tailings ponds with in situ development. The waste is injected into deep aquifers underground, and so that has risk to contaminate groundwater resources. So this is just from a report card that we released last week at the Pembina Institute, where we compared all of the different in situ operations that were operating in 2007. And this is just to show the water use intensity and how much it does vary between projects. So not everyone is using best available practices, and that definitely is something that the government needs to provide incentive for. And then it's compared against mining there at the bottom of the chart. Freshwater intensity, although most companies are trying to use as much saline water as possible, there are still projects that are using a fair amount of fresh water, even for in situ. So companies are definitely making strides to improve their water efficiencies on a per barrel basis. But as you can see, the forecasted production rates, they're expected to potentially even double within the next decade. And so a lot of those per barrel improvements could be negated by a drastic increase in production.